Hello, everyone. Welcome to session 1 of day 1. My name is Alicia Sarah, and I will be the moderator for this session. I would like to introduce the speaker for this session, Hayden Barnes. Hayden Barnes is fascinated with WSL, started a WSL company, and now WSL is his full-time job. In this session, Hayden Barnes will deliver a talk about powering AI or ML workloads with Python, Docker, and CUDA on Windows 10 with Ubuntu on WSL. So please give a huge virtual applause for Hayden Barnes. The stage is yours.
Thank you to PyCon Indonesia for inviting me to speak today. Sulamat Siang. Thank you for joining me for this presentation. In the next 30 minutes, we will cover who am I, what is WSL, why you might use WSL, how to set up an AI/ML workflow on WSL, and a quick demo of how that would work. So who am I? My name is Hayden Barnes, and I'm the engineering manager for Ubuntu on WSL at Canonical, the company that publishes Ubuntu, as well as Microcates, Juju, Snapcraft, a bunch of other cool stuff. I've been working on WSL for about 3 years now. I started Penguin, a WSL-focused distro, a few years ago, and then I moved over to Canonical to lead WSL efforts on Ubuntu. I am, ironically enough, a Microsoft MVP on Windows development. My contact information is below, so you can find me on GitHub, Twitter, LinkedIn, or send me an email with follow-up questions. To start, a little disclaimer. I am by no means a Python expert. I did once write a mainframe front end. It identified litigants, those are participants in lawsuits, and mailed them letters from lawyers who wanted to be their lawyers, ads. It talked to a custom IBM 2970 interface. It verified data against public record databases and then talked to an API that actually mailed physical letters to unrepresented parties from lawyers who wanted to represent them. The code is bad. It was my first major Python project. Didn't go anywhere because it turns out people do not like finding out they have been sued. But it was a fun project, and I'm glad I did it, and that is my Python experience to date. But what is WSL? WSL at its core is a Linux terminal environment for Windows. You can run most Linux applications and services on Windows with WSL with a relatively high degree of interoperability compared to previous VM or container solutions. WSL is very lightweight. It boots to a shell prompt in under 2 seconds on most devices. It lets you use Windows and Linux tools side by side, including piping the output back and forth. That's one of my favorite tricks. WSL 1 was a system call translation layer introduced in 2017 that translated Linux binary system calls into NT system calls. WSL 2 is a very thin virtualized container with a real Linux kernel running at the core. This shipped in Windows 10 2004 earlier this year and has since been backported to Windows 10 1903 and 1909. The advantage of having a kernel there improves compatibility dramatically. So what are some things you can do with WSL that you couldn't do with traditional Linux VMs or other containers? Well, it's pretty easy to access your C drive. It's mounted there for you. You could run bash scripts that call Windows applications to automate your workflows. You can even pipe the output between the applications. One of my favorite is to pipe the output of a Linux command to clip.exe, where I can then paste it anywhere using the Windows clipboard. You can even run Windows applications from WSL. Here's an example. Notepad.exe. There you go. That's very simple, but that's just one example of the things you can do with WSL when they come together, and that's the most interesting part for me. So why use WSL when there are so many other virtualization options out there? The number one reason we hear people using WSL is because your employer is Windows only. They may just be dabbling in Linux now, looking at Linux in the cloud, and WSL is a way to get started there, especially if you're managing hybrid cloud ecosystems. Your employer may have legacy .NET applications running on Windows Server that they want to save money on by moving to Linux, containerizing, and putting on the cloud, like Azure. WSL is a great way to do that. Or you might be learning Linux for the first time and you're not ready to dual boot or rent a VPS or pick up a Raspberry Pi. And with WSL, you can try Linux on your existing machine without additional cost or a lot of fuss. For the most part, it's just a few steps, a reboot, grab a few things from the store. We'll cover this in a minute, and you're good to go. Last and finally, my favorite purpose is you want to build and test cross-platform Linux and Windows applications simultaneously. You can build a version for Linux, you can build a version for Windows, and then test them side by side. So if you build that Windows version in WSL, you can then just run it with the .exe. Or you build a Linux application in Visual Studio, and you can run it and test it right then and there in WSL. So we're seeing a lot of cross-pollination in terms of tools between Linux and Windows increasingly. So how to get started with WSL? Today we are going to start with a rather advanced use case. Some of this is kind of out of the realm of what you would normally do when you were just getting started on WSL. I'll try to make that distinction to show what you can do on your machine now versus some of the extra steps that we have to do in order to get it running with CUDA and AIML and all of those other things we want to do. The great thing about WSL is, like Linux, it is what you make of it. So you can take it and build on it what you would like. So for basic WSL2, you need Windows 10 1903 or higher. I recommend Windows 10 2004. You'll need to enable WSL 1 and 2 manually. I'll show that in the next slide. And you'll need to get Ubuntu from the Microsoft Store. This is on existing stable releases of Windows. Now for our purposes, we will be on the Windows 10 Insiders dev channel. These are bleeding edge builds of Windows 10 from Microsoft. It's actually a lot easier to set WSL2 up on these images with new features coming like wsl.exe --install. We'll also need a Nvidia CUDA capable GPU, like a 2070 Super, which I have in my machine here. And we'll have to get the latest CUDA drivers, which I will cover momentarily. So let's say you don't have a CUDA GPU and you just want to get started with WSL. Right now, it's a little bit of a process. For non-insiders, you will need to enable WSL, then enable WSL2. Then you'll need to install the WSL2 kernel, set WSL2 as your default, which I recommend, and then you'll need to install Ubuntu from the Microsoft Store. Those are detailed here. Now, I hope to make this deck available at a later date, so if you need to copy and paste from here, you can. Now, if you're on an Insiders dev channel, it's a bit easier. All you need to do is open a PowerShell prompt as administrator and type wsl.exe-install. And everything that we saw on the previous slide will be handled for you. So these features, the wsl.exe-install will eventually land in stable Windows releases, probably sometime next year. Once you get WSL2 installed, I highly recommend picking up the new Windows terminal as well from the Microsoft Store or GitHub. It is a very nice experience over the legacy Windows console. The only caveat I have there is that for some non-Latin alphabets, which may affect some users who are watching this presentation, the console may still be a better option, but it's worth trying both in my opinion. So here's my Windows terminal on my production machine. It is a custom Ubuntu theme. We are working on getting this theme out there so that you will get that very Ubuntu-like experience when you install Ubuntu on WSL. Otherwise, it's pretty generic, but we're getting there. But now that we have WSL2 up and running and installed, you can see welcome to Ubuntu 20.10. You can see I'm at my bash shell. I'm on my C drive in my Windows home folder. You can also change that default home folder in the Windows terminal settings in a JSON file. Okay. Next thing we will need after getting WSL2 set up is the latest pre-release Nvidia drivers to support WSL on CUDA. To get there, you will need to enroll in the free Nvidia developer program, kind of like how you need to enroll in the Windows Insiders program to get those builds. And you'll need to download the latest pre-release drivers. These are bleeding edge drivers. And eventually, when this feature goes stable in Windows 10, these drivers will be bundled in the standard Nvidia drivers that get delivered by Windows Update, but they're not there yet. One caveat is to please keep in mind that installing Windows Insiders dev channel and pre-release Nvidia drivers can introduce unforeseen bugs into a production system. I recommend doing this on a second system if you have one. I don't know about you, I don't have an extra system with a 2070 Super GPU in it. So what I do is I dual boot. I have two Windows installations on my computer. One for my gaming, let's be honest, that I want to keep stable, and one where I can go in and use these advanced tools with the pre-release software. And I'm a little more tolerant of those bugs that come up on the pre-release software. I file feedback and bug reports when it happens. Occasionally you get a blue screen, or in the case of Insiders, a green screen of death, and it happens. When you're on the bleeding edge, you can get cut and bleed a little, but that's where we are. So we install those latest NVIDIA drivers after enrolling in the NVIDIA developer program. Pretty straightforward if you've ever done this before. And then you verify in the NVIDIA control panel right there that you've got it installed and you are ready to go in terms of that component. We're not quite there yet. So just to recap, we've got WSL2 enabled. We've got Ubuntu installed with that wsl.exe-install on Insiders dev channel. We have the latest pre-release NVIDIA drivers through the Nvidia developer program. And then we've gotten those installed. So what do we do now? With our WSL and Nvidia drivers in place, we're ready to begin building on our WSL environment. First thing we do is we install Docker. And my personal preference is to install Docker directly from the Ubuntu archive. You could also install Docker from the official Docker repositories. But it's good practice to refresh those package repositories with apt, sudo apt update, and then install Docker with sudo apt install docker.io. All right, so we've got Docker installed. Next, we need to install the NVIDIA Container Toolkit with the runtime for Docker to access the GPU. This is a little more complicated. You see a lot there. What we're doing is we're detecting the distribution, we're importing a key, we are creating a custom app repository entry for our NVIDIA Docker repo, and then we're installing that key to verify that repository. These commands are on the next slide, but this is what it looks like when you're done. So these are the commands. We're detecting the distribution there by echoing out from our OS release file. We're then grabbing that GPG key for the repository with curl and importing that into apt. We are then grabbing the apt repository list and exporting that to our apt sources directory. You can see that here. So we're grabbing that, we're grabbing the curl and moving that here, just the same way we did this GPG, which we then added to the apt key database. And then we're also installing the experimental drivers, because we'll need experimental drivers for this to work, and it will install those for us. So once we get those repositories installed and the key in place, we run sudo apt update again. Apt is the package manager for Ubuntu. You'll see in this list here that in addition to checking these Ubuntu repos, which we saw before, we're also now checking those NVIDIA repos where we're grabbing the runtime, we're grabbing NVIDIA Docker components, and experimental libraries as needed. You'll also see that I have not run package updates on this image in a while, which is bad practice. Everyone should run sudo apt update and apt upgrade regularly for security purposes. Don't do what I do. All right, next, we've got those repositories installed, we've got the key imported. Now we're going to install that NVIDIA Docker runtime. Sudo apt install NVIDIA-Docker2. Now this Y will do it automatically. That's just a habit of mine. You can leave that out and it'll prompt you just to tell you what it's installing, how much space it's going to take, and will generally be more interactive. But this is an automated install. All right. Okay, now what's going on here? We got a lot going on here. Okay, to make sure everything is set up, we're first going to start Docker manually. I did that here. Let me change pen colors just to mix it up a little. We've got sudo docker d. Remember, WSL isn't completely like regular Linux. It doesn't have systemd or traditional init. So some of these services we have to start manually, and that's what we're doing here. And then we're opening the second pane. How did I open the second pane? I clicked this drop-down box. I picked Ubuntu while holding down the Alt key. And that opened a second pane over here with a second terminal in the same Ubuntu instance. And what you see we've done here is I run sudo docker run using our GPUs. We want to use all of our GPUs, and we're grabbing a container from the Nvidia container repository. We're just grabbing a sample container that runs a simple benchmark. It doesn't find it locally, so it grabs it, downloads it, and then we can run it. So zoomed in here, here's that command. After pulling in that container, we have a working container in WSL2 connected to our GPU. You can see here, we got my GeForce RTX 2070 Super. You can see we got just over 5,800 GFLOPS. So we've got access to our GPU now within our Docker container using the Nvidia runtime. So this just keeps things super clean, super simple. You don't have to spend a lot of time configuring a lot of things. Sometimes third-party tools aren't yet aware that WSL can support GPU acceleration, and they just kind of give up. They're not really sure what they're looking for. They're looking for a traditional GPU and not the WSL GPU. So I find just running things in the Docker container basically enlightens the container, and everything in the Docker container runs much more smoothly with this runtime. All right, so we've got WSL2, we've got the Nvidia drivers, we've got Docker, we added the Nvidia repository and the Nvidia runtime, and we've now run a sample Nvidia test container to verify pass-through. So what can we do now that we're at a Python event and we want to use PyTorch? Let's grab the PyTorch container from the Nvidia repository. Grab that. Meanwhile, we can kind of see that over here that Docker is doing its thing in the back end. But we're going to pull that NVIDIA container and start working with it. Okay, now that we've got it, we're going to run it, but you're going to see some settings here that are a little bit different. So we're running that Docker container with all GPUs like before, but we're running it interactively. So once we run, we drop to a shell within the environment. This is a little bit of a security issue, but we're going to share memory between our container and the host WSL container. You can also specify exactly which memory you want to share, but for now I just went with IPC host. Now here I have a volume option, and I am mounting via WSL my desktop folder, which is automatically mounted at Mount C, and I'm mounting that within my container to data desktop. And then I'm running the same, pulling the same container we pulled before. So here we have PyTorch. Occasionally when you run PyTorch, you'll get a little message that no NVIDIA device was found and GPU can't be used. That's a known bug. If you check the release notes, it is definitely there. And if you run NVIDIA SMI, it should be detected. But that's how we fire up our PyTorch container. Right. So we've got our PyTorch container. You can now start building and testing inside that container. Here I have cloned a sample project. Just some examples from PyTorch. Git clone those into a folder, went into that folder, made sure I installed our requirements using pip. Most of that was satisfied except for pillow, and then we are pretty much good to go. We have an AI/ML workstation. Um, in terms of working with this moving forward, you can then clone and edit the source of this Docker file from the Nvidia container registry and run a custom version. But I really recommend using Docker build to add your customizations on top of the standard registry container image, just so that you can move Python dependencies, right? Python dependencies are complicated, just so you get smoother migration as those containers get updated and the underlying get updated, and you just avoid issues. So use Docker build if possible. So because we mounted a volume in the container to our Windows file system via WSL, we now have a little examples folder right here on our Windows desktop. On our Windows desktop, we can now, if we wanted to, feed data sets directly into our Docker container from Windows. You can also open your Python in code. You can also make any other changes you need to. See, the key is every workflow is going to be different. So I installed Docker completely inside WSL just because that's what I'm used to. There is also Docker Desktop for Windows, which has a WSL backend, which offers similar functionality. It's just going to be personal preference, and I highly recommend that you experiment and try what works best for you. But to recap, we enabled WSL2 on Insider's dev channel. We did that with the caveat that dev channel can sometimes be a little unstable, so we're not necessarily going to move all of our main production machines to Insider dev channel right away. We then installed the latest Nvidia CUDA drivers from the Nvidia developer program. We installed Docker. I installed Docker inside WSL. You can also install Docker Desktop for Windows, which hook into WSL. We then downloaded a test container to verify that we had CUDA functionality within our Docker container within WSL2. I then git cloned an example of a PyTorch project and set it up and ran and began training some data sets on some public data sets. And then, as you can see here, thanks to the interoperability of WSL between Linux and Windows, mounting that folder in the Docker container inside WSL and then reaching out to Windows where we can access that data directly. The only caveat I have about that is that crossing data between Windows and WSL is going to introduce a little bit of a bottleneck. So if you're doing gigs and gigs and gigs of data, you should go ahead and just move that over to the WSL side. You shouldn't do that across the Mount C barrier. It'll just slow things down a little bit more than you need to. But once you move it over to the Linux side, you can, on the Insiders dev channel, you can always access it from the quick actions in Windows Explorer or from //WSL/Ubuntu in File Explorer, just like as if it were a Samba directory. You can access your Ubuntu file system there. So thank you. Silamat Tinggal, appreciate your time. Thank you for joining me. Again, I will make this deck available to the PyCon ID organizers so they can be shared. And you can follow up with me via email, GitHub, Twitter. I'm pretty much all over the place. Thank you so much. Bye-bye.
Okay, I think this is a pre-recorded session, so we didn't have the Q&A live session, but thank you so much for Hen for the session and for all of you who participate in this session. And let me close the session and see you in other session. Bye bye.